Hi everyone, and today we are going to see about the hysteresis motor. So an hysteresis motor, it is defined as an synchronous motor. Here it having the cylindrical rotor that work on the hysteresis losses. In previous class also we seen what is the meaning of eddy current losses and what is the hysteresis losses. That is it will be broadly classified as according to the constant losses and variable losses. Already we seen in the transformer and motor losses. So here the main principle behind the hysteresis motor. Here the motor is work on the hysteresis losses which is induced in the rotor of an steel with high retentivity. So here it is a single phase motor, and here the rotor is made up of ferromagnetic material with non-magnetic supported over the shaft. So the constructions, there are 5 main components: stator and stator winding, it is a single phase winding, and rotor, there will be a shaft, and shading coil will be there. These are the components of hysteresis motor. Stator. So here the stator is designed to produce synchronous revolving field from the single phase supply, not a 3-phase power supply. So with the help of a single phase power supply, we have to induce the synchronous revolving field. The stator carries 2 windings, one is called main winding and another one is called auxiliary winding. The another type of design of hysteresis motor, the stator holds the poles of standard pole and the rotor. The rotor is made up of magnetic material. It has high hysteresis loss property. The rotor should contain high hysteresis losses. Example, chrome, cobalt steel, alnico or some other alloys. The hysteresis loss becomes high due to the large area of hysteresis loop. If the hysteresis loop is high, the losses is also high. The rotor does not carry any winding or any teeth. The magnetic cylindrical portion of the rotor is assembled over the shaft of non-magnetic material like brass or etc. The rotor is provided with high resistance to produce eddy current losses. And this is the schematic diagram. So there will be an auxiliary winding will be there and main winding will be there. So this is the main winding and auxiliary winding. The auxiliary winding is also called, this is for starting winding. And in between the stator and the rotor, there will be an air gap will be there and a rotor of chrome stool, and the outer part is nothing but stator and inner part is nothing but rotor. So in between the inner part there will be a shaft will be there. So around the shaft the rotor is wounded. So here the main principle behind the hysteresis motor and single phase induction motor running behavior like a synchronous motor. Okay, so here the single phase induction motor is normally it is called asynchronous motor, but this is running just like a synchronous motor, that is under constant speed 1500 rpm. So at the starting condition, an stator is energized by using the single phase AC supply, so it produces rotating magnetic field in the stator. And in order to maintain the rotating magnetic field, the main and auxiliary winding must be supplied continuously at the starting and as well as running conditions. At the time of starting, the induction phenomena, the secondary voltage which is induced in the rotor by stator rotating magnetic field, the eddy current is generated to flow in the rotor and it develops the rotor. This eddy current which is produced along with the hysteresis torque in the rotor, the torque which is developed in the rotor magnetic material with high hysteresis loss property. So the rotor goes under the slip frequency before going to the steady state running condition. So based on this hysteresis losses, it will be operating under this, it will start under the starting condition. And under the running condition, the speed of the rotor reaches nearly about the synchronous speed. The stator pulls the rotor into the synchronization. So when the power supply is given into the rotor and it will be pulled into the synchronization. So at the condition of synchronous system, the relative motion between the stator and the rotor both are same. So there is no further induction phenomena to continue. So there is no eddy current. It will be generated in the rotor. So the torque due to eddy current vanishes. So this is the advantages. As no teeth and no winding in the rotor, so no mechanical vibration that will takes place under the normal operating conditions. This operation is very quiet, noiseless, as there is no vibrations. It is suitable to accelerate inertial loads. Multi-speed operation can be achieved by employing various gear shift. And this is the disadvantages. It is low efficiency, low torque and low power factor. Okay, this type of motor is available in very small size only, not in a big size. And these are the few applications: sound producing equipment, sound recording equipment, high quality record player, timing devices, electric clock and teleprinter. Just you can see the applications. These motor can be in small size, not in a big size. And this is an assessment. In a hysteresis motor, hysteresis torque remain practically, it is variable or fluctuating or constant, or it may be zero. So put your answer in the comment section. And these are the few references. Thank you.